Fusing neutrals was a common practice in electrical wiring systems from the late 19th century until the early 20th century. The primary reasons for fusing neutrals were protection of equipment, simplification of troubleshooting, and prevention of neutral-to-ground faults. In early electrical systems, neutral wires were often used as the return path for current. If a fault occurred, such as a short circuit or ground fault, the neutral wire could carry a high amount of current. Fusing the neutral wire limited the current flow and protected equipment from damage. Fusing the neutral allowed electricians to disconnect the entire circuit with a single fuse. This simplified troubleshooting by isolating the fault to a specific branch circuit. If the neutral wire was unfused, a fault between the neutral and ground could create a dangerous situation. Fusing the neutral prevented this by interrupting the current flow in the event of such a fault. However, fusing neutrals also had significant disadvantages, including the risk of electrical fires, loss of power to multiple circuits, and complication of circuit protection. If a fuse in the neutral wire blew, it could leave the circuit without a neutral path. This could lead to an imbalance in the system, causing overvoltage and potentially sparking electrical fires. Blowing a single neutral fuse could interrupt power to multiple circuits on the same panel. This could create inconvenience and safety hazards, especially in commercial or industrial settings. Using fuses in both the hot and neutral conductors made circuit protection more complex and difficult to manage. It was necessary to find and replace both fuses in the event of a fault. Due to the potential safety hazards, the National Electrical Code, or NEC, prohibited the use of fused neutrals in new electrical installations in 1927. This code change gradually phased out the practice of fusing neutrals in existing installations.